Mic check, mic check. Let's see. All right. Good morning, good afternoon, depending on where you are in the world. So last week we started off with this stream where we are trying to practice speaking out loud and solving these LeetCode problems. So one of the feedback that I've gotten while doing some technical interviews is that I get really quiet sometimes when I'm trying to do these problems. So I felt like this would be a good way to work on that. Okay, so last week we did pretty much all of the array and strings. Today we'll be doing, we have one left, string compression. But I figured out that maybe we should probably leave that for later and then try and knock out one section. So the 2 pointers is pretty doable in one day. It's too easy to medium, so that's what we'll be focusing on today. So 2 pointers. It's a pattern where pretty much we use 2 indexes, so 2 like variables or something, to move through a list. So maybe the I and J looping that I'm so fond of. So normally you have one start at the start of the array and then one at the end, and you move. So you can do for I in like the array count, and then for I plus J, for J, I plus 1 if you want to move. You don't want to do the start and end thing. You want to do the start and then the next one, and then you can move them both at the same time. But the idea is to just use 2 pointers to move across the list. So, I mean, it should be better than using a nested loop, and the time and space complexity should be less. Okay. So let's go to our first question, which would be move zeros. And let's see. Maybe I should open these before. Doesn't take too long. Okay, move zeros. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. Note that you must do this in place without making a copy of the array. So example 1, we have an array of 5 numbers, 0, 1, 0, 3, 12. And then we get 1, 3, 12, 0, 0. The second one, we have 1, 0, and we output 1, 0. So this is fairly simple to understand. So we're getting an array of numbers, and we just want to move the zeros in the array to the end while keeping the same order of the non-zero numbers, as well as not creating a new array. So you want to do it in the same array, because a simple way you can do it is just make an empty array, and then you can loop through. Anytime the number isn't 0, you append it to the new array, and then probably just count how many zeros you encounter when you're going through the loop, when you're going through the array with the loop, and then add that amount of zeros to the end. So yeah, let me actually do that way first, or array where we loop through. So first thing first, I need a way to keep track of where the zeros will be, or where to place the non-zeros. So let's do our first loop, which can be for I in nums, which is what is being passed in. I don't know why I keep doing 1 instead of I. Okay, we're now off to the greatest start. For I in nums dot count. For I in 0 dot nums, we want it to be less than the count. Okay, so the first loop, and then what we want to do is if the I in nums, we use the I as an index for nums. If it's not equal to 0, we want to move it. Okay, we need some way to keep track. Yeah, so do var let's use index, var index, we set it to 0, and then if nums with our I is not equal to 0, we're probably going to increase the index. But then we also need to so if it's not 0, we want to place it at the position. So if the number is not equal to 0, we want to place it where the index is. Our index tracker is. So we'll use nums, we'll pass in the index, and then that would be equal to the nums, and that shit scares me. We're equal to the I position, like this. Okay. So that's the first loop. This will get us high 1BP7L. What's up? So this loop will get us all the non-zero numbers. So if we're using this, it would get us 1, 3, 12. And then we need a way to add the zeros to the end. So we have 3 numbers. The loop is 5. So we can use our index. While index is less than the number of items in our initial array, our index is less than nums dot count. And what do we want to do here? What we want to do is if we go through here, so we want to just place a 0. So we'll do the same thing, nums, use the index as our position. We set it, and then we also want to move our index up by 1. I believe so. Okay. So let's do 0, 1, 0, 3, 12. First index is a 0, so it skips this. It is less. So 0 is less than 5. So 0. Okay. 1. Next is 1. Okay, this should work. For I in nums, I gotta start with the body. Am I missing something? If what? Am I missing a closing bracket or something? Or is it this space? Damn, so picky. Okay. So this works. Let's submit and see the runtime. So this doesn't actually use the 2 pointers, since it can be optimized, but it still runs pretty well. I don't know why, because we're going through it twice, even though we're not using an extra way. We're doing it for the zeros, and then we're doing it again for the zeros. So let's see. Let's actually try and use the 2 pointers. 2 pointers, 2 pointers, 2 pointers. So we can have, instead of this variable, okay, let me just uncomment all of this. Let's do this. Okay, so instead of having an index, we can just have a var start position, which is, I mean, it's pretty much the same. 0. Sometimes the runtimes are not so accurate. Oh, okay. So I was right. That it's probably slower. The time complex. Yeah, I know. I need to study more on the time complexity and the space complexity. What they actually will be. I know that's one of my one of my weaknesses. But I know the space will be O1 because, I mean, we're doing it. We're doing the things in place without like creating a new array. And I think the first one I did that I've commented out will be it'll be on. Yeah, I think it'll be a on or on squared. But this one, I think with the pointer it should just be on. The time should be on. Perfect. So the time will be on. Because I'm gonna, with this 2-pointer, I should only have to do it once, go through it once. So I have a start and I have a right, an end. So the end will just be the nums count minus 1. And I'll do a for loop that way. So that should be linear. Perfect. So I have my start position, and then so we want to do end position for end position in nums, and we want to do -1 because we want the last. We want to start from the end. No, we don't. For end position and nums that count. Oh no. I'm doing too much. Let me go. I think Swift has a swap. I'm thinking too much. Swap. The two arguments not be next to each other. Is this swap? Exchange? With unsave? No. Swap at. Yes. So we have our 2 pointers already. We have our I and J as start and end. Exchange of values at a specified indices of a collection. Okay. Oh, okay. Let's see. So, where is it? Okay, here. So we can do swap, but we need to check for the 0. We need to check. So it's my name and that's throwing me off because this shouldn't be end position. So we can do if num does not equal 0. Oh my god, if num does not equal 0. So if it doesn't equal 0, then we can swap our start position with our number. And then we move to start position. That should work. No, it's not this. Where nums like this. If nums number does not equal 0, then we want to swap, and then our start position will move, I think. Start position plus equals 1. We need to do the swap before we move this. Exchange the values that are specified in these. I hate that it doesn't give us examples. So I'm gonna do nums swap at start position and right. Okay. So I'm like doing comments. Yeah. So yeah, I tried to. I do it in my head, but yeah, I need to start writing them out. Thank you for the suggestion. Yeah, I need to write down my thought process. But this should work. Let's run and see. Int conform sequence. Oh, I didn't do the 0. Silly me. So it was just 1 for num. Cannot find start position. What? Cannot find start position in scope. Can I not spell? Yes, I can spell. Yeah, that way you can be on the same page with the interviewer before proceeding to code. And it makes it easier to write out code. Yep. All great suggestions. It's a lot more different doing it by yourself than having someone to ask questions. But yeah, I totally understand. Like, to write more pseudocode. Okay. It's still saying the 0, but like we said, the runtime can be totally different. Okay. I think I need to last non-zero found out, so they're using okay. Simplest solution. Okay, they're also using a swap. Beats 90%. So this is like a normal 2-pointer, 2 variables. Also using a swap. This is a lot of code. And if else is else. Old me would have loved it. What's this, like a map? Filtering twice, creating 2 temporary arrays, and then combining the results. This is not efficient and probably now. I'm probably not what an interviewer wants to see. And why do you think it's not effective? I think this should be the top. Okay. Of course. For I and num, where num is not equal to 0. This does not beat 90% anymore, I think, but still clean code. Okay. One down, 4 to go. Okay. Okay. Let's do a medium. Max number of k sum pairs. Let's close this. You're given an integer array nums and an integer k. In one operation, you can pick two numbers for where. In one operation, you can pick two numbers from the array whose sum equals k and remove them from the array. Return the maximum numbers of operations you can perform on an array. So we have an array 1, 2, 3, 4, k equals 5. So what we want to do is get two numbers that equal 5. If they do equal 5, we remove them, but then we also need to increase the number. We need a variable to keep track of how many pairs there are. So first, variable to keep track of answers of pairs. So we can do number of pairs. Oh my goodness, of pairs equals 0. Okay, so once we're looping,